multiple angles and product sum formulas. So we did some multiple angles for the first half of this lesson. Remember we did like sine 2u. Now we had seen that before back when we were solving equations. They gave us those double angles. But again, the reason it's called a multiple angle is you're taking u and multiplying it by 2. That's a multiple of an angle. So today we're going to pick up some multiple angles as well, but these are going to be half angles, where we're going to take u and multiply it by 1/2. So half of u would just be u over 2. And so that's where you get the 4 formulas that we are adding today from page 414. This is the half angle of sine. So sine u over 2, half angle for cosine, cosine u over 2, and half angle for tangent, tangent u over 2. So those are called our half angle formulas, and they are multiple angles. You'll notice that there are 2 different formulas for tangent. We do want to know both of those, so we want to memorize those 4 formulas off of page 414 for tonight. Okay, so here's how we're going to use those formulas. They are going to give me a triangle or some other information in order to come up with values. So like they might tell me sine is equal to -5/13, or they might give me a triangle with the -5 and the 13 on it. We've seen them ask us that in both ways in the past. So for our first example, they tell me sine is equal to -5/13, and theta is in between 3 pi over 2 and 2 pi. Find the sine of theta divided by 2. Okay, well the first thing I need is my formula. So I can come up here to the formulas that we picked up today and say, okay, sine theta divided by 2 is either a positive or a negative square root of 1 minus cosine theta over 2. So to complete that formula, I got to know what the cosine of theta is. So I'm going to come over here, and if they had not given me the triangle, I could build it from this information, and I could say, okay, sine is opposite over hypotenuse, Pythagorean theorem to get the other side. Have you seen those triangle values enough to know what that other side is without Pythagorean theorem? 12, yes. The only thing I wouldn't know is whether it's positive or negative, and that's going to depend on the quadrant that I'm in. So that's why they had told me that theta was in between 3 pi over 2 and 2 pi, so that I would know I was in the 4th quadrant. So of course in the 4th quadrant, then I can say cosine is positive. All students take calculus, positive in the 4th quadrant. And I can look at my triangle and then say cosine is adjacent over hypotenuse. And so my cosine is 12/13. So again, that's not new for us. We've been doing that for quite a while now, where they either gave me a triangle or they gave me one of the trig functions, and we utilize that to find the other trig function. So we're good up to that part. We've been doing cosine is equal to 12/13, that type of thing. Now we want to slot that into the new formula that we picked up today. So the formula is sine u over 2. So we're going to replace cosine theta with 12/13. When I get to that point, I'm done with the trigonometry. Now I go back to joyful algebra, right? Simplifying fractions with radicals and rationalizing and yeah, all that fun stuff. All right, so to begin with, if I have 1 minus 12/13, what's that going to give me? 1/13, right. So now I have 1/13 divided by 2. Dividing by 2, same thing as multiplying by 1/2, right. When we divide fractions, we multiply by the reciprocal. So if I do 1/13 times 1/2, I'm going to get 1/26. And you don't have to write all those steps. I'm just writing every little detail to make sure you see where we got those. We're not going to leave a radical in the denominator. So we're going to multiply top and bottom by the square root of 26. And we'll get square root of 26 over 26. Now, right now, we have a plus or minus out in front of this formula. If you think about what this formula represents, pick any value for theta that you want. Okay, let's say theta is 50, okay? If I say 50 divided by 2, I'm getting the sine of 25. The sine of 25 is not positive and negative at the same time. So I'm either, when I get down here to the end of my problem, I'm either going to have to say it's positive or negative, one or the other, but it is not going to be both. This is the first time that we've ever had to do this in a problem, where we had to figure out whether something was positive or negative based on the quadrant that it was in, in two different places in the same problem. And here's what I'm talking about. You remember back here, we've already figured out that theta was in the fourth quadrant, and so the cosine there would have to be a positive 12/13. We've already done that. But now we're trying to figure out the plus or minus out in front. That plus or minus is for the final answer, so that goes with the sine of theta divided by 2. So I need to think about, where is theta divided by 2? If theta is between 3 pi over 2 and 2 pi, I want to figure out where theta divided by 2 is. Now, we've seen this before, that when you divide any part of this inequality by 2, you have to divide the whole thing by 2, right? So I'm going to take 3 pi over 2 and divide it by 2. That would be 3 pi over 4. And I'm going to take 2 pi and divide it by 2. That would be 1 pi. So if theta was in between 3 pi over 2 and 2 pi, divide all of those by 2, and theta divided by 2 will be in between 3 pi over 4 and 1 pi. Where is that? Where is 3 pi over 4 to 1 pi? What quadrant? Second, yes. So that means that theta divided by 2 is in the second quadrant. So that tells me what my answer will be over here. If theta divided by 2 is in the second quadrant, and we were looking for sine there, sine in the second quadrant is positive, so we're going to give a positive square root of 26 over 26. Now look how important that is. If I had gone back to the original information and gone back to this fourth quadrant, sine is negative in the fourth quadrant. So I would have erroneously come up with a negative value over here instead of a positive. Okay. All right, these red numbers circled over here represent the homework problems that are going to coincide with the particular examples that we're doing. And for 31 through 38, they're going to give me problems like this, but all of them are going to be in the first quadrant. So if you have answers that are, or thetas that are between 0 and pi over 2 in the first quadrant, and you cut that in half, now you're between 0 and pi over 4. You're still in the first quadrant, right? So the nice thing about that is, for that first block, they were really nice to me. Everything's in the first quadrant. Everything's positive. Everything's happy. And so then when I get down to 47 through 50, there's just a couple of those, but that's where they're going to give it to me in a different quadrant that I'll have to compute these two different signs. So we wanted to do one of the more challenging ones as our example instead of one of the easier ones. All right, example 6. For example number 6, they asked me to find the exact value of the sine of 105. That means they don't want me throwing it in my calculator and getting a decimal approximation. They want the exact value. Okay, how am I supposed to know the sine of 105? And I don't want to memorize a whole bunch of additional facts on top of the ones we already know. So here's what I can do. I can rewrite 105 as something divided by 2. What divided by 2 would give me 105? 210, right. So I'm going to rewrite 105 as 210 divided by 2. You could literally write that as an equation for yourself. Like, you literally could say 105 is equal to x over 2, multiply both sides by 2, and you get x is equal to 210 if you needed to. All right. So this, I can go back to my formula. And so you'll notice that in my formula, 210 is in the place of u. So I just need to put a 210 in the place of u. So it would be the square root of 1 minus cosine 210 over 2. So down here, square root of 1 minus cosine 210 over 2. How does that help me? Well, I know the cosine of 210. So that's a value that I can find, where I couldn't find the sine of 105. So I want to rewrite an angle that I don't know using an angle that I do know. All right, so cosine 210. We've been calculating these since like section 4.4. So that's all the way back to the beginning of January. So good review for us. If I want to find the cosine of 210, I'm going to have to find the reference angle. So I can say reference angle for 210 is 30, and then find the cosine of 30 degrees, which is square root of 3 over 2. Then I have to figure out whether it's positive or negative based on the quadrant that it's in. So I can say, okay, 210's in the third quadrant, so I'm going to have a negative of the cosine of 30, and that's going to be a negative square root of 3 over 2. All right, so since we know that the cosine of 210 is negative square root of 3 over 2, then let's go ahead and put that in. So now we've got 1 minus a negative square root of 3 over 2 divided by 2. Minus a negative is going to be plus. And if I'm going to combine 1 with the square root of 3 over 2, I'm going to need a common denominator. So I might as well just go ahead and write 1 as 2 over 2, right? So we'll say 2 over 2 plus the square root of 3 over 2, and that's being divided by 2. So again, I don't really know that it's the trig that's so challenging about these as much as it is the algebra with all the fractions and radicals. Dividing by 2, same thing as multiplying by 1/2. So in my numerator, that'll give me 2 plus the square root of 3 times 1. So the square root of 2 plus the square root of 3. And perfectly fine to have a square root of a square root. That's just a fourth root. So not a problem. You don't have to like try and simplify that or rationalize that or something. You can leave it that way. In the denominator, we had 2 times 2, which was 4. So of course the square root of 4 is going to give us 2. So now we're done with the exception of this plus or minus out here. Because remember we said, you know, we were trying to find the sign of 105, right? The sign of 105 isn't going to be both positive and negative. It's going to be one or the other. So where is 105? What quadrant? Second, right. And what is sign in the second quadrant? Positive. So we're going to say, since 105 is in the second quadrant, we're looking for the sign there. It's positive. So we're going to choose the positive value for out in front here. Now, we also have a random circle of red numbers over here. For 51 through 54, they're going to have us work backwards. Like, they would give me something like this, a positive square root of 1 minus cosine 10 divided by 2, and they would want me to work that backwards to the sign of 105. Okay, well, how am I going to do that? I'll look at this and say I have the square root of 1 minus the cosine of something. These are the only two that have a square root in them, and this is 1 plus the cosine. So it would have to be sine u over 2 if it's 1 minus cosine over 2. So I could say, okay, that's the formula for sine u over 2. And whatever I was taking the cosine of is u, so I'm going to put 210 there. And 210 divided by 2 is 105. So in that case, they would give me this and ask me to work my way backwards to the sign of 105.
So what happens to that 1/2?
All right, then on the bottom of page 415 and the middle of page 416, they give us 8 new formulas. These are the product to sum formulas and the sum to product formulas. You do not need to memorize these. I will give you those 8 formulas. So the 4 formulas on 415 and the 4 formulas on page 416, I will give to you. What you have to be able to do is look at those 8 formulas and choose what is the correct one for your situation and then know how to use it correctly. So all you have to do is be able to choose and use, choose and use. So example 8. For example number 8, they ask us to find the exact value of cosine 5x times sine 4x. All right, that's a product, right? So that I can't be using a sum formula. I need a product to sum formula. So that means that I'm using the formulas on the bottom, page 415. So on the bottom of 415, I have sine times sine, cosine times cosine, sine times cosine, and cosine times sine. So for ours right here, we have cosine times sine. So we're choosing that fourth one. Do you see why we chose that? Because you have to be able to choose the correct one. Everybody see where we got that? Okay, then once I choose the correct formula, I'm just going to write it across the top here. Then how do I use it? Well, I'm going to go through and I'm going to put 5x in the place of each u, and I'm going to put 4x in the place of each v. So 5x in for u, 4x in for v. 5x in for u, 4x in for v. And then, of course, we can simplify a little bit. 5x and 4x is 9x. 5x minus 4x is 1x. I cannot combine sine 9x and sine 1x. I know we think there's got to be some way we could say like 9x minus 1x is 8x or something like that. Those are not like terms. Remember when we were trying to solve equations earlier and we were unable to solve when we had a double angle and a single angle at the same time because we said they're just not the same thing? It's the same thing going on here. This is 9 times an angle and this is 1 times an angle. They're not like terms. It'd be the equivalent of like trying to say x to the 9th and x to the 1st. You can't subtract them and get x to the 8th. It's not the same thing. And so they stress to us again that sine 9x, you can't like pull that 9 out in front and say, I have 9 sine x's so that I can subtract 1 from it and get 8 of them. I can't combine those. This would be my answer, or the other way that I could write this, if you wanted to distribute that 1/2, you could do that, but you wouldn't have to. So you could distribute the 1/2 through or leave it factored out, either one. All right, then example number 9, they say write the exact value of cosine 195 plus cosine 105. So this time they're giving me a sum. So I need to use the sum formulas on page 416, right? Not the product ones on 415. So let's look at 416. On 416, I have sine plus sine, sine minus sine, cosine plus cosine, and cosine minus cosine. And if you'll notice, we have cosine plus cosine here. So do you see why we're choosing the third one there on page 416? Do you see why we did that? Okay, because again, we got to be able to choose the right one. All right, now we want to use it. So if I want to use it, I'm going to go through and put 195 in for x and 105 in for y. So again, I'll come over here, 195 in for x, 105 in for y, 195 in for x, 105 in for y. All right, so 195 and 105 are going to add to 300, and 195 minus 105 is going to add to 90. And you don't have to write that as a separate step. I just didn't want to confuse anybody, but you surely could do the 300 divided by 2 in your head to go to 150, and then 90 divided by 2 in your head to go to 45. So again, we've been calculating cosine of 150 for about a month now, but just good review for us. We could go through and say, to find the cosine of 150, I need the reference angle. So 150 is 30 degrees away from the x-axis. So cosine 30 is square root of 3 over 2. And then I need to figure out if it's positive or negative based on the quadrant that it's in. 150 is in the second quadrant, and cosine's negative there, so I'm going to get negative square root of 3 over 2. So we could go ahead and put that in for cosine 150, and of course cosine 45, and then just multiply to simplify. Again, something that they stress to me is that cosine x plus y, you cannot distribute that cosine to the x and that cosine to the y. That was our cosine addition formula. Cosine, cosine, minus sine, sine. Remember that? You can see we get something totally different here with our sum formula. So they just reiterate to us what we had seen before.